This session is about CSOM and REST API. My previous session was about apps. And apps is how, the way apps talk with SharePoint is through REST and CSOM. So if you need to learn apps, you must know REST and CSOM. But at the same time, even if you're never going to write an app, REST and CSOM is a worthwhile thing to learn. Because REST and CSOM keeps your code out of SharePoint, and it allows you to write reliable code and functionality that appears inside of SharePoint. So, my name is Sahil Malik. I run a small company called WinSmarts. My contact information is on the slides, and these are a couple of my books. If you need a copy of these, just shoot me an email. I'll send you a free copy. My email address is on the slides. And with that, let's dive straight into the actual content. So, client-side technologies in SharePoint. So, we live in a different world today. A lot of us use Facebook, etc. People are getting used to an environment where we are writing applications that feel like desktop applications, right? So they're very rich applications, but they're running right through the browser. And the enabling technology behind all of that is browsers getting more and more powerful, right? And we run a lot of like AJAX queries behind the scenes, and that's how we're able to load everything on demand. So for instance, when we talk about Facebook, for instance, so next time when you log into Facebook, run Fiddler on the site and look at how many AJAX requests or parallel requests does Facebook execute in order to be able to load its homepage, like right after you log in, right? Imagine if each one of those requests had to be done sequentially. The site would be absolutely unusable. I compare it to, like going to a restaurant and ordering, say, steak and broccoli, and then when a dish shows up, instead of broccoli, they brought potatoes. So, say, hey, I needed broccoli, I don't need potatoes. And imagine if they took your whole dish back and then they brought you another dish with maybe something else on it, that's what it feels like. But when we talk about AJAX and these technologies, we're able to have the advantage of both thick client apps that we're able to serve rich applications, but at the same time be able to deliver it through a browser, so no installation issues. But for any of these technologies to work, obviously on the client side you have JavaScript, but you need something on the server side too, right? Something that listens to all those AJAX requests. And in SharePoint, that is either you can write a custom WCF service, which works in SharePoint 2007, 2010, or 2013, right? You can do that. But so I was the person who sort of pioneered writing WCF services inside of SharePoint in the SharePoint 2007 timeframe. In 2010, that was still a pretty good option. In 2013, I almost suggest not to do that, right? Sometimes it still makes sense to do that, but usually I say, no, if you don't need to do it, then we should try and stay away from it. So I try and stick with REST and CSOM API now for two reasons. Number one, REST and CSOM API has grown a lot between the last version and this version. And what that means is that the API has grown, it's gotten a lot more powerful, right? So we can do a lot more with it, things that we couldn't do earlier. And secondly, if I write a custom WCF service now, it's a farm solution, and the farm solution, they're not going to be future compatible. As we go to the cloud and everything, they're not going to be future compatible. Why did Microsoft create REST and CSOM? Because frankly, SharePoint is a sausage factory. For those of us who work with SharePoint, I think all of us, you will agree that there are a lot of moving parts inside, a lot of intricacies, difficult to do code isolation. I can step over your code easily, and it can be argued that the SharePoint object model isn't the best, right? That's another issue. So they gave us REST and CSOM, so we don't have to work inside that API, and we can write our code outside that API. And as a result, our farm stays much more reliable, and we have an easier way of deploying things as well. So again, why did Microsoft create REST and CSOM? Because today we have a need for distributed computer systems, right? All the code is not running on the server. I may pull out my phone and connect to the SharePoint using my phone, for instance. The rich applications are running inside the browsers, and obviously apps cannot run any server-side code on SharePoint. So even if apps use server-side code, they are still talking with SharePoint using REST and CSOM. So again, why do we need to learn REST and CSOM because 80% of the code we're going to write is probably going to be apps and at least in a well-run projects, right? And so 100% of that app code talking to SharePoint is going to be REST and CSOM. So we have to learn REST and CSOM. And even if you never write an app, REST and CSOM is still the better way of writing code. In fact, I would go to the extent of saying that if you can deliver some functionality using REST and CSOM, you shouldn't be doing anything else, right? You should not be writing server-side code working with a server-side API if that functionality can be delivered using REST and CSOM. So REST and CSOM are here to stay, that's for sure. But there is another sort of like, fundamental paradigm shift that we're going through in the IT industry right now. So I don't know about you guys, but when I started programming, I started with functional languages, right? There was one start point, usually like main method or something like that, and then my logic would call function after function after function, and that is how my application would work. Then a few years later, object-oriented programming came along. And with C++ and so on and so forth, I had to start learning new concepts. And within a few months, I understood all the concepts, like what is an abstract class, what is an interface, what is inheritance, and I could clear an interview, and I could get a job. But it still took me 3-4 years to properly understand an object-oriented way of thinking, right? And 3-4 years later, when I finally got it, right? Today, when I look at things around me, when I look at this, for instance, this inherits from a base class called C candy, right? My head works like that today. And I would argue that today we're going through a similar paradigm shift again, right? And the similar paradigm shift we're going through again is synchronous versus asynchronous programming. And this leads to some interesting challenges that we have not faced before. So us as architects, or programmers, we've always looked at code like this. We say where data is equal to download data, and by the time process data runs, the data variable already has data in it. So while download data is running, code execution stops right there. So the problem with this is that between download data and process data, we just wait, right? And imagine if this was Facebook and there's 80, 90 parallel requests that it executes, you'd have to wait for each request to finish before the next one could start. Not very efficient. Asynchronous, on the other hand, is a little bit like this. You do download data async, and you continue execution. And when the call returns, then process data gets called, right? Now, you're like, well, yeah, I've seen this before. Tell me something more interesting. And the thing over here, the main difference here, is that I can do other things in the middle. All major languages support this. Like WinRT APIs, for instance, anything that takes more than 50 milliseconds, and that's, by the way, almost everything, you're supposed to call it in an async way. Even opening a file from the disk should be done async now, right? But this requires some interesting challenges. For instance, let me ask you this. If I put a try catch around this block, and if an exception is thrown in process data, will the catch block catch the exception of process data? See, some people say yes, some people no, and some people are unsure. So just a simple thing as try catch, okay? Just a simple thing as try catch. Now, what if there were 3 async calls going on? And what if one of them failed and process data was never called? Would the catch block be called then? Right? So these are the kinds of challenges we have to think of. So for instance, how do you do error handling? So when you start working with async code, you have to think of error handling as 3 different kinds of errors. One is a timeout error. Hey, I couldn't reach the endpoint, right? Address is wrong, right? Second is a communication error. I could reach the address, but the channel is faulted or something like that, right? And third is a logical business error that you can recover from. Customer without first name is a required field. That's an exception you want to catch and you want to return from. And you deal with those differently. So generally speaking, you would have a success handler and an error handler. You must have seen this in all async code over and over again. And generally speaking, the error handler gets called, when you have non-business logic errors, like a communication error, for instance, a protocol error, concurrency exception, something like that. But there are a lot of times when we, as developers, we end up muddying the two, and then it becomes very hard to maintain such code, right? Now remember that it's not just one such block that is running, right? Because remember, you can have many such error handlers and failure handlers, but then there's another thing that we need to worry about. And the other thing we need to worry about is that you might have timing and gating issues. For instance, I may want to, complete 4 of these calls for the 5th call to succeed, right? Maybe the 5th call takes the 4 calls as inputs. How do I do that? How do I establish that? JavaScript doesn't have threading, so how do I just stay in a while true loop until these calls return? What if I don't know if it's 4 or 6, or I have an unpredictable number of calls that must execute before the 5th call executes, right? How do we handle that? That's another challenge that we didn't have to think of earlier. And remember, all of this, just keep thinking in the back of your mind that as I'm structuring all this, how do I structure my code? How do I put a try-catcher on all of this? If I put a try-catcher on all of this and the exception is thrown in the last block, will the overall catch call it or not? How do I handle that? And then the other issue we have to worry about is concurrency. Because by definition, when we are working with async code, there are a lot of delays. Because in 10 years ago, when internet was sort of new, and if I wanted to download a 5 megabyte file from a server in Tokyo, it took about half an hour. But if I pinged that server, the ping request took about a second. Today, I can download that 5 megabyte file almost instantly from Tokyo, but the ping still takes a long time. And the ping is actually limited by the laws of physics. It's not going to go down. So this is a problem that is not going to go away with time, that the ping times and the latency is going to be quite a lot in these distributed systems. And that is a challenge we can't get around. So when I'm working on the server, I can simply query the server, right? I can simply query the server, and I have the entire content database there. Anything that I want to read, I can read it right away, not a problem. But when I'm working in the browser, the paradigm we follow over there is that I decide that I want to get these 3 pieces of information or 4 pieces, and then I go to the server, and that takes some time, right? Maybe half a second or so. And then I get that data, and I work with that data while I'm far away from the server. Now I'm working with the data, and in the meanwhile, you came in and changed the data that I queried. And in that scenario, my updates must fail, because my updates are based on facts that are no longer true, right? That is called as concurrency issues. And again, just think of all of these together. You have gating issues, you have timing issues, you have exception blocks, you have concurrency issues, and you want to keep your code, easily readable, manageable. How do we solve all this, right? So you see that writing async code is not that simple. So there are some challenges that async code introduces that we didn't have to worry about earlier. Error handling becomes a lot more interesting. Timing issues, concurrency. How do we solve all these problems? The answer is that all of these problems have solutions. Some of them are unique to the platform you're working in. Some of them, you have a standard solution in the backend API. For instance, error handling. Error handling in C# is generally a try-catch block, right? And generally speaking, what you do is that you would write your exception handlers in a certain way that you carry the most specific exception at the top and the least specific exception at the bottom. And never send .NET exceptions over the wire. As long as you follow some best practices, you'll be fine. And generally speaking, in C# we say that you must always catch an exception, because you don't want to throw an exception over the wire, because that corrupts your channel, right? Because exception is a .NET only concept, right? So that's what we do in C#, but honestly we'll be writing a lot of JavaScript going forward. So what do we do in JavaScript? Try catches in JavaScript are extremely expensive, right? Try catches in JavaScript are extremely expensive. How many of us are writing JavaScript over here? Okay, JavaScript is getting pretty popular, isn't it? It's the only language that runs all the way from your phone to the server. It runs everywhere, right? So next year, most probably I'm going to do a 1-day workshop on JavaScript, right? So that, if you're interested in that, it might be quite interesting. But anyway, error handling in JavaScript, try catch can be done, but it's very expensive. So generally we avoid try catches in JavaScript. What is better in JavaScript is that you handle the window.onError method. And what I like to do is that I handle window.onError, but then I look for a query string. And I don't show that error to the end user unless that query string value is passed in. So that way, if there's an error, this frequent JavaScript will throw errors, but things still sort of work. But if things don't work, I don't want a dialog to show up, but if I say, and debug is equal to true, then, I want to see the entire error message. And that I would do using window on error, because the error will bubble up, and I want to catch the global error event, so that way my JavaScript runs fast, right? And at the same time, I don't have try catches all over the place. Structuring JavaScript code is not easy. It's a science in itself. Timing issues. Again, in C# and .NET, we've got the async await keywords, right? And in JavaScript, you have deferreds and promises, right? And deferreds and promises also can affect your performance quite a lot. So that's jQuery. The deferreds and promises jQuery concept. So we all use jQuery. So if you're using jQuery, deferreds and promises, you said $when, .then. This underneath the scene that is important to realize that a simple statement like this that we copy paste all over again creates two deferreds underneath the scene. So if you put this inside of a loop, you could potentially bring your browser to a grinding halt. Right? So these are things that we have to consider when writing such code. Now let's talk about concurrency. Concurrency, the challenge is that a lot of users are updating data at the same time. How do we maintain the sanctity of the data? Right? Now, there are different approaches to concurrency. The classical approach is pessimistic concurrency, in which we say we're going to lock the data. Right? So if I read the data that I might update, I'm going to put a lock on that data, prevent anybody from reading it or updating it until I submit my changes. That's not going to work in distributed systems. Because I get the data, the user hits the X on the browser, goes for lunch, that's not going to work. So generally speaking, we use a different way of concurrency in distributed systems called as optimistic concurrency, in which we don't do locks at the database level or the resource level. Instead, what we do is that we get the data, we perform the changes, and then on save, we would check if the data that I had queried is still there, right? And there are three ways to do that. One way to do that is to check for every single column, which is very safe but very slow. The other way is that I check for only the columns that I'm changing, which is less safe but better performing, depends on the platform of course, because databases will cache queries. And the third and the best way, which everybody's moved to, is that generally speaking we have an ID on the row, like Oracle will have like a row ID or SQL will have timestamp. REST API has got something called as e-tags. And e-tags is a number that increments every single time anybody updates that data. And in fact, REST API in general and in SharePoint by standard basically says that when you persist data that you're updating, so on updates and deletes, you need to pass in the e-tag that you're querying on the data that you're trying to update or delete. So if you don't pass that in, your query is not going to succeed. And they enforce that, and that is how REST API does it, right? CSOM does it slightly differently. CSOM underneath does something very similar to this, but CSOM has got another concept called as the concept of object identity. And what object identity is something that is baked into every distributed Microsoft platform, right? And what it's a entity framework does it too. Link to SQL did it. Link to SharePoint did it, right? And other frameworks do that as well. What object identity means that if I have queried for an object, right, and I do repeated queries of the same object, and in the meanwhile, if somebody else changes that object on the server, the newer version is simply discarded in my queries. So I query, and I'm doing another query of the same object, but the object on the server has changed, right? And the new version comes in, and my code will look at the newer version and say, hey, this version has changed, I'm just going to toss it. I'll just work with the old version. At the face of it, that sounds like a terrible idea. I'm throwing away newer versions, that sounds bad, but actually it's not bad. Think of it this way, that I have a static variable. Now we know what a static variable is, right? With the two functions, they can share their value, for instance, as one thing that a static variable gives me. But if I'm writing both these functions, if I change the function variable, the variable in one function here, the other function is going to get that same value instantly. But the difference over here is that I'm controlling this whole picture, right? I wrote function 1, and I wrote function 2, and I wrote this variable. So I can write reliable code on this assumption because I'm controlling both ends of the spectrum. But in a distributed scenario where I didn't write what the other user is going to do, I have no idea. Then how could I write reliable code against data that keeps shifting under it? I can't. So we discard older versions. It guarantees that to my code the data looks reliable. And then when do we check for concurrency exceptions? When we save the data. For all you know, the user may never hit the save button. 50% of the scenarios they don't, right? When they hit the save button is when the data goes to the server. So those of us who are familiar with CSOM, you know that there's this object called client context, right? So client context, a best practice in that is you should have only one client context, like Highlander, they can be only one, right? Now the reason for that is if you have two client contexts on your one JavaScript page and they're sharing the same variables, to SharePoint it looks like it is two different clients. And invariably you're going to step over each other and you're going to get a works on my PC sort of a problem. And these errors are going to be very, very hard to diagnose. So, but the general theme of all distributed systems, REST and CSOM and others, is that generally speaking we query data and we have exception handlers at all these steps. Then we work with data and then we save our changes. And then we're going to run this loop over and over and over again, right? So, a quick comparison, again, the steps are going to the server, working with data, saving your changes, concurrency and all that. So the steps are, in CSOM, going to the server is done using two methods on the client context object. Either execute query or execute query async, right? In REST API, we would use, using JavaScript jQuery, we would use $.get, $.get JSON, $.ajax. Like that's typically what we would use. What do you say about concurrency checks? CSOM has got concurrency checks, object tracking, and object identity built into the API. We don't have to do anything about it, we get it for free. So I mentioned object identity. What is object tracking? It's basically that if I change the title of the SP Web object, CSOM remembers that the title was changed and it tracks it for me and it sends that delta back to the server next time I go to the server. Right, so it tracks all that for me. In REST API, I don't get object tracking. It is my responsibility to remember all of that. I have to write code for it. CSOM does that for free. So data objects, the business objects I work with, you know why they call it the client-side object model? Because all the objects that hold data inherit from a base class called Microsoft.SharePoint.client.client object. SPWeb, SPList, SPList item, all of these eventually inherit from client object, right? So that's why we call it the client-side object model. And those are the objects we will be working with. Whereas REST API, we make the query to the server, and then we get a JSON or Atom XML or something like that back, and then we have to craft up our own object based on that. Yes, JSON will give me an object. JSON itself is an object. But at the same time, I have to sort of craft up the structure myself based on that. So, the usual application, CSOM, usually it is more convenient to use that in server-side code. And I say usual because there are exceptions to this rule. Some things don't work in CSOM, some things don't work in REST API. And usually, it is easier to write REST code in JavaScript. Personally, I prefer REST. And that is because of the last point, community support. Because anytime I get stuck on a CSOM problem and I Google for something, it's only the SharePoint guys that are, twiddling with CSOM. REST API there's a lot of support for REST in the world. So if I'm looking for a data grid that works against an OData data source, I'll probably find one that works with REST, right? But with CSOM, I have to write my own, usually. But at the same time, REST is a lot more chatty in nature. So CSOM gives me a somewhat better API also. And sometimes I don't have a choice. Some of the things I want to do, I have to pick one or the other. It doesn't matter, what I'm trying to do. The API isn't there. So I have to pick one or the other. The good news is that in 2013, 80% of the functionality is common between the two. So I don't have to pick in most cases. I can pick the one I like. And then security, both REST and CSOM, piggyback on the user's identity by default. So if I'm logged into the browser, then the request running on the server is running as me, the person that is logged onto the browser. And they also work with apps, so they can also tag on, the OAuth token on top, right? The access token on top, and so on and so forth. So basically either browser security, piggybacks on browser security, we also call it transport security, and OAuth. So let's dive deeper into CSOM. So again, remember that, concept of, we execute a query, we work with the data, then we go back to the server, right? So we run that in a loop. So in CSOM, the way this works is that step one, you would create an object called as client context, right? It is in the Microsoft or SharePoint .client namespace, and the proxies for this namespace are available for JavaScript, for Silverlight, for Windows Phone, and for thick client apps. So you would create a client context in whatever platform of choice you pick. Next, client context has got methods on it called .load and load query. And load query don't actually load the data. They allow you to specify what data you would like to have loaded the next time you go to the server. Right? So load query don't load data, they allow you to specify what data you would like to have loaded. And then you would execute query method or execute query async. Generally speaking, we will always run execute query async. So the client context for thick client, Windows Forms or WPF give you execute query also. But that doesn't mean that we should write unresponsive apps for Windows WPF and WinForms. The reason they've given us that API over there is because the assumption is that the platform you're working on can do threads on its own. So you handle the threading. They're giving you that choice, right? But we should not write, we should make these calls on the UI thread. Otherwise, the UI will be completely unresponsive. But generally speaking, if you're working with Silverlight or Windows Phone or JavaScript, you're going to call execute query async. And execute query async will allow you to give two method handlers, success and failure. If the call succeeds, the success method gets called. If the call fails, the fail handler gets called. So then assuming that the success method gets called, you're going to get the data. Then you can work with the data, you make changes to it, and when you want to go back to the server, you call execute query and execute query async again. And then you're going back to the data and you're sending only the changes that you are persisting. So the important thing over here is that the programmer at all times was in control of when a round trip is done to the server, which is when you call execute query async, and what is received from the server and what is sent to the server. You are in complete control of that. So again, the way it works, I have a sequence of commands. I execute queries. Internally, it will send the results as XML, and then it gets back JSON. So it's a little hard to read, it's a little small, but how do you create a client context? You have three ways of doing that. Either you can specify the URL as a string, or you can specify URI object, or you can just say client context.current. Why did they give us this current object? Hey, if you have one on the page, you shouldn't be creating more. Right? So if client context.current equal to null, then create it. That should be the pattern. So create a factory method to get client context. That's the best way to do it. Then load methods, you got two choices there, either load or load query. And load query accepts an iQueryable T. Okay? iQueryable generic is a link query, and load accepts a link expression. But the important thing over here is that where T is of type client object. right? And that's an interesting limitation that we must remember. Let me see if I can, no I can't, never mind. So, alright, let's do that. So you see over here that the T client object is something that, it has to inherit from client object, which means that when I get data from the server, the data that I'm getting back from the server has to be of type client object. In other words, I cannot create an arbitrary projection of the data that I'm getting back. So I can get list items, okay? But like say if I'm querying the context list, so I can get the context list, I can get the contact list items, but I can't say they'll get me only the first name and last name. And where this becomes a challenge is when you go to 3 levels deep and you want to write nested link queries. So imagine that I had a situation where I have a parent SP web that has got an undefined number of child SP webs, and all of them are based on the same site definition. And I know that in all of them I'll find the announcements list, and I can go that level deep with just one round trip to the server. But if I added another requirement there and I said, look, now you need to get me the first list item in all of those lists, you cannot do that in one round trip. You have to do 4 round trips now for 3 list items. Right? That's the limitation it puts on us. And then execute methods, it's execute query or execute query async. Right? That's how we can go back to the server. Client objects, as you see that the server-side object model lives in Microsoft.SharePoint namespace. Client-side lives in Microsoft.SharePoint.client, Microsoft.SharePoint.client.silverlight, and the JavaScript objects live in sp.js. So in my last session, I wrote a simple app which was loading the sp.js file, and that is how I was able to use the client-side object model, because I was loading that sp.js file. Now you also notice that the object naming is a little bit different. Like, generally speaking, the .NET classes, they have an object called sp-site, sp-web, whereas in JavaScript they just call it site and web. Okay, well that's easy to remember. But there's an interesting difference down here. And that is that I have .title on C# like objects, but when I talk to JavaScript, I have getTitle and setTitle. Why did they create this difference? Why are they making our lives harder? Because of object tracking, right? What happens is that in .NET, even though it's a property, it's really syntactic sugar. A property is 2 methods underneath the scenes, getter and setter, right? But what happens is that in the setter, when I'm changing the value, they have a hook in there in which they remember that you changed this value. So they can store somewhere in the class that this particular property was changed. Why do they do that? Because next time we go to the server, we should save it. JavaScript doesn't have this concept. In JavaScript, a property is just a dereferencer. Now, yes, we could write some code that could watch for properties changing, but that code does not perform. Right? Like you have these frameworks, Knockout.js, etc., that allow you to do that, like MVVM, etc., but their biggest problem is that they don't perform well. Right? So AngularJS uses some other interesting workarounds to that, but still, the problem is that for a whole framework to do that, at a global whole scale level, it's not going to perform well. So they gave us 2 methods, get and set. And when you call set, it'll remember that you changed a property and it'll remember to send it back to the server. Okay? Now, another thing that you will see is that, so SharePoint objects have got, say SPWeb has got a property in it called quick launch enable. It's a boolean, true, false. Now you'll see that when you work with CSOM, and let's say you're getting the SPWeb object, not all properties are fetched, right? So sometimes it can be confusing that is that property part of CSOM or not? So the rule of thumb over there is that properties that are static data types are fetched in one go. Example, spweb.quicklaunchEnable, that will be fetched. spweb.masterURL, that will be fetched. spweb.allowRSS that will be fetched, because these are static data types that are right on SPWeb object. What won't be fetched is sp.lists, because that's a collection. To get the collection, you have to explicitly specify that I would like to load .lists, .content types, right? So static individual variables are, loaded anytime I load the one object, and then the collections are loaded, like, I have to ask for it. Now, I can ask for spweb and spweb.list in one go. Like, I don't have to create a second round trip for it, but I have to ask for it. That's one rule. The second rule is that the objects that I'm getting back, even static objects or collections, generally speaking, the objects that are present in the client-side object model have to meet two criteria, either of the two criteria. Number one, that they have to be static variable types, like a string or an integer or a boolean or something like that. And the other criterion that we must meet is that it must fall in the Microsoft or SharePoint namespace. For instance, there's a property on SPWeb called UI culture. You'd think that, hey, why didn't they send this information back? But the problem is the UI culture is not in the Microsoft or SharePoint namespace. It is in the system.globalization namespace. So you'll see that that property is missing in the client-side object model. So just remember these two rules, and you'll be able to pretty much guess, that what CSOM can do and what CSOM cannot do. So in America, one of the things is that we never get to deal with multilingual issues. I don't know if that's the case over here or not. But at least in America, when we write code, rarely ever will we have to deal with multilingual issues. But in Europe, multilingual is a big deal. You cannot ignore it. I can't how many times, I'm writing this code, I'm like, well, yeah, UI culture should be there, because based on that, I want to do something different. Like if you're in this UI culture, I show you the currency in this format, otherwise I show you the currency in a different format. Guess what? Can't do it, right? Because the UI culture is missing. There are workarounds to it, of course. Now let's talk about load versus load query. Both of these examples of code that you see over here are of equivalent complexity. Right? The first one at the top is getting all lists, basically the title, where the hidden property is false. And the second example is getting all lists where list.hidden is not equal to false. Right? But both of them are solving an equally complicated problem. But which one of the two is easier to read and easier to understand? First one? First one, this one is easier? So, this reminds me of a little joke, a little detour, but there's these two programmers that went out for dinner, right? And they have a nice dinner and they want to go home, but one of them spent all his cash, right? And he tells the other guy, hey, can you loan me $50 so I can take a cab back home? I'll return it tomorrow. And he goes, hey, you just want me to make it 64? It's easier to remember, right? So I have run into the situation where people look at this and say, this is easier to remember. This is easier to understand. No, it's not. This is easier. Because this looks more like English. Right? Yeah, this is more programmer friendly. Sure, I get that. But this is a little bit easier to remember. Right? So when you do .load is easier if I was loading just the SPWeb, if I'm loading an object. Right? But if I have a more complex condition in there, if I'm loading a collection with some conditions, generally speaking, it's easier to write a link query. But the important thing to remember is that any link query can be translated into a link expression. So technically, you could use one or the other. And another segue, another point that I'd like to make over there is that when you're using JavaScript, you don't have link in JavaScript. You've got something called JS link, which looks like link, but you can't use it with CSOM. So in JavaScript, frequently, we have to write somewhat more complicated code when working with CSOM. In C#, we can use link, no problem. Link is beautiful. Now let's talk about updating data. What are we doing over here? Now, to update data, I first have to query data. Right? Because remember, I can't just update, I have to query and then update. Exception being inserting new data. obviously, because that's not there, so I can just insert. So over here, I'm changing the title of the site. I say my context.load. I say my context.web. So I'm loading the SP web. Now I've loaded it after I call execute query. Once it is loaded, then I change the title. Right? I change the title and then I say my context.web.update, which doesn't update, it marks it for update the next time we go to the server. And when do we go to the server? When we call execute query. Similarly, the lower example you see over here, I'm adding a new list. When does the list get added? When I call execute query. So again, execute query versus execute query async. We're probably going to just use execute query async, but one is asynchronous and the other is synchronous. Here's a code example of uploading a file using CSOM. And there's a landmine embedded in this piece of code that you need to be aware of. And that is the largest file you can upload using this API is 1.5 megabytes. Why did they put this limitation in there? I don't know. Right? But all I can tell you is that it bit me once. Right? So I'm telling you that be careful of this landmine, you might step on it. So whenever I upload stuff, I always use REST API. How do you use CSOM? In Silverlight, you add these references to your project. I have a 1-hour video in which I'm writing code and talking about CSOM. There's a video is available right over here if you're interested. Right? So I'm not going to be showing Silverlight here because who the hell uses Silverlight anymore? How do you CSOM in Windows Phone? These are the references. The code is very similar. And how do I add CSOM in pure JavaScript? Like this. But what if my client is not SharePoint? What if my client is PHP? Can I use CSOM in that? It's JavaScript. I should be able to, as an app, right? I should be able to. And the answer is, yeah, you can. You just have to hand add the references like that. Okay? Setting web properties. I have lots of code examples over here. So, like SP web, SP list, SP site doesn't have this, and SP web application have a property bag on them. It's a great place for me to save some information. That property bag is accessible over CSOM. Getting list items, right? Here's a code example of getting list items. So I say web.getList.get by title. Now the important thing to remember over there, when you say get by title, you're writing the display name of the list, not the internal name. Right? So that might be a little confusing. And I say items is equal to list.getItems, and then load query, execute query async, and now I get the items. By the way, that items.forEach works in every browser except Internet Explorer. So you see the pie chart, making everything work in all browsers and then making everything work in Internet Explorer. So there is this, my God, I can't believe I forgot this. You might be able to tell me what this is, but there is a library there's a JavaScript library that removes the differences between all browsers. Like if you don't have a feature, it will give you the feature written using a JavaScript method. Like items.forEach, items is an array. ForEach is not a method available in IE10. So this library will see if you don't have ForEach, it will add it for you.
It's about modernizer.
Modernizer. Yep, exactly. Actually, I did remember that. But cool. So, yeah, Modernizer is awesome, right? There's this set of JavaScript libraries. I tell you, Modernizer, AngularJS, Breeze.js, these three together, it's the best combination. It's awesome. Anyway, so then you have context.execute query async, another example over here similar. And then here's another way that you can structure your code, and this is called as method chaining. So you can use JavaScript to your advantage and be able to write code that is a little bit easier to read. Like when I look at this, it's pretty clear to me what's going on over here, right? So I can do method chaining. I'll say context of get web, get list, get by title, get items. With one glance, I can tell exactly what's going on over here, right? I'm getting the web, the list, and the particular list name and items. Method chaining, right? So if I write my code this way, With this one line of code, I have the ability to, fetch exactly what I want, and I can look at my code and tell exactly what's going on. You have the ability to CRUD operation, and it's a little small to read, so I'm not going to bother going over it, but these are some code examples. You're going to get these slides, but some code examples will show how to, create, retrieve, update, delete data. It's possible using CSOM. So with that, let me just, show some code examples using CSOM, and then we will dive into REST API. This talk is supposed to end at 3:30, right? Okay, cool. So here is my SharePoint VM. And let me just grab some sample code that I have. So this is all out of my training material, but I have a simple console application here. And with the simple console application, it's a 32-bit console application. It's not even 64-bit. Because it's not running within SharePoint. It's going to talk to SharePoint using CSOM. Let's load this. Okie dokie. Let's go ahead and open reference. It's still thinking. Hourglass. Right. So you see here, I have added two references. Microsoft.SharePoint.client and Microsoft.SharePoint.client.runtime. They've been added from the 15/ISAPI folder. That's where I found those. Because I'm writing a thick client app, so those are the references I would add. If I was doing Silverlight, I would go to Layouts, Client Pane, and I would find two DLLs with the same name in there. Now, once I've added those references, we'll go to program.cs, increase the font size a little so we can read this. And you see here that I am hitting a site URL called http://sp. And then I have a big using block, right? Now the cool thing here is that if I don't call using, I'm not hurting the server. I'm hurting the client, but I'm not hurting the server. But still, if you see dispose, call it, right? So client context, my context is equal to new my client context site URL. And then the first example here is that I'm loading a simple object. My context.load, my context.web, and do execute query, console.writelet. At the end of it, it should write out the title of my site. And I'll tell you, I'm just going to warm up my SharePoint site if it isn't already warmed up. It's thinking, okay. I can tell you that the title of my site is test. So when this line of code is done running, it will write out the title as test. Now, I'm also going to run Fiddler on the site, and the reason I'm doing this is because I want to see exactly when we're going to the server, and I want to be able to see what information is being sent to the server every time we go to the server. Okay, let's wait for SharePoint to warm up, and it's there. Pretty fast, isn't it? And I'm going to go ahead and hit F10 and start debugging this. F10, see IntelliTrace is working on the site, that's pretty cool. F10, my context.load, okay? That went over pretty quick. Why? Because we haven't gone to the server. I'm going to come back to Fiddler. Nothing. We haven't gone back to the server. Now I'm going to hit F10 one more time. And you see that now I'll run execute query, and now is when I go back to the server. And you see it's thinking a little now, right? And it threw an error. Okay, internal server error. What the hell happened? I just love it when these things happen in a demo. Double click, system.service model service activation exception. The same memory issue. I should probably create a separate VM for demos, but I mean, you've attended most of my sessions, you know what I'm about to do here, right? So basically, like, my server is running out of memory, and I'm just going to create some memory, and CSOM will start working again. So it'll take 2 minutes, and this will be back and up running. So. Now, how many of us here actively work on SharePoint on a day-to-day basis? Okay, so you're used to this, right? Things don't work in the first go. It's all right. Manage services on server, open a new tab, manage service applications. I should just write a PowerShell script for this. Okay, let's find this search service application, delete, Okay. Distributed cache, stop. Okay. So this should give me lots of memory.
How much memory you got in your box?
The machine has got 16. The VM has been allocated 12. So it's a little less for SharePoint. So all the WCF services fail when it's got less than 5% memory. But you see that I just start distributed cache and I got another gig back, and I'm going to delete search, and that will give me probably another 4 or 5 gigs back, and that's enough. See, look at that, 7.8. So now I have enough memory. So I'll come back here and I'm going to try my code one more time. Now it should work. Because it talks to client.svc. That's a WCF service. So it was failing. F10, 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 F10. Let me clear out Fiddler, because now we have lots of junk collected here. F10, that's going to think a little. All right, come back here. Now see what's going on over here. When I call execute query async or execute query is when I went to the server. But when I go to the server, first it calls sites.async. Okay, and it calls it anonymous, and sites.async replies saying, hey, anonymous not going to work, but I accept NTLM. Then the next request, it passes the NTLM token. And this request succeeds. Finally, I call sites.async, and I'm able to get a few things here, right? So let's go to raw, actually let's go to XML, and it gets me the digest value, timeout settings, URL, library version, and all of it, okay? Now, why is this important? When you work with Office 365, you're going to find those variables very, very useful. So if they update the library version, when you write Office 365 code, you should check the library version, and if it gets updated, you can give the user a message saying, hey, we haven't tested our code with your library. Or you can load the appropriate version based on library. This is a challenge everybody's running into Office 365, that things change on the server without any warning to you. Okay, let's come further down. Then the request gets executed up here, as you can see, and it sends the request as XML, right? And the results come back as JSON, and it's getting the SP web. And you see here that it gets all the properties like, hey, object identity. Remember that object identity, which is basically what it does is that it takes the ID of the site, GUID, and the web, and it concatenates them. If I was getting a list, it would concatenate that on top. If it came the list item, it would concatenate all of those. So it gives me a unique object. So that is how it is able to check the identity of the object, and if it finds like a new version coming from the server, it'll just discard it. It can just discard it blindly in all cases now, because it can just check with this particular property. Object type, allow RSS feeds, app instance, configuration, blah, blah, blah. And you see I get a lot of things over here. What I don't see over here is lists, because that's a collection. Now, I'm going to cheat over here, okay? I'm going to say I will comment out going to the server, and I'm going to try and access this title without going to the server. Let's start again, F10, boom, I'm going to get an error. Property or field not initialized exception. And if I was accessing a collection, it would say collection not initialized exception, right? So I have to go to the server to be able to get this information. Okay, let's go and run it one more time, F10, 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 execute query. Okay, now let's get a collection. Let's clear out Fiddler. And what am I doing here? I am basically, running a simple, a crazy link expression where I'm saying list.field is equal to false. Hidden is equal to false. Right? List.hidden is equal to false, and then I get those lists, and I'm going to write out their titles. So my context of web.list, again, let's come back to Fiddler. Okay, and okay, I cleared out the details. What I wanted to show you was that it doesn't like re-authenticate you over and over again. So basically, in a well-designed system, you see a second authentication over here inside of Fiddler because I turned distributed cache off. Okay, And this is one of the common issues you'll see with a lot of SharePoint environments, is that distributed cache is not set up properly, or SharePoint is not able to talk to distributed cache properly. So if you looked at SharePoint 2010, and you look at, run Fiddler on SharePoint 2010, and assuming that it's set up with claims-based authentication, you will see a cookie in the headers called as the fed-auth cookie. And the fed-auth cookie is, if I took your fed-auth cookie and wrote it down on a piece of paper, went on a completely different machine, and replayed that fed-auth cookie into the server, I'd be able to authenticate as you. Okay? Now, so you should not lose your fed-auth cookie. So that's okay, because theoretically everything should be HTTPS, which I'm sure we're all running our SharePoint 2010 installations under HTTPS, right? Are we? Nobody is. Now I'll tell you one thing. With apps, do not run without HTTPS. Right? Must HTTPS with apps, even on an intranet. Because without HTTPS, I can just get a hold of your access token using something as simple as Wireshark, and the access tokens are good for an hour. So I can do whatever you are doing as you using that access token for up to an hour. It's very easy for me to crack into your INT. So do not run SharePoint 2013 without HTTPS. In fact, today, don't run any system without HTTPS. Why? Okay. So, but you see here that I'm double re-authenticating over here now? Because I thought I had already authenticated when I went over this line of code. Why do I have to authenticate again? The reason is, in 2013 they made a little change where they keep the fed-auth cookie on the server in distributed cache. Why did they make this change? Because A, it works better with load balancers, but the bigger reason is that WebKit-based browsers, Safari and Chrome, they will cut your cookie if it gets more than 64 KB. And if you look at I know I'm going a little off track, but this is sort of interesting, so I'll mention it. So I'm going to go to inetpub, www, WSS, virtual directories, 80, notepad, web.config, and I'm going to search for a word. I hope I'm looking in the right. Yeah, no, not that. Yeah, here you go. See this? Microsoft identity model, save bootstrap tokens is equal to true. So SharePoint not only uses, WS Federation, which is okay, no problem, but it uses something called as bootstrap tokens. And actually a lot of people use bootstrap token is very common. Like if you're using Azure ACS or using any other middle tier identity provider, you will be using bootstrap tokens. The problem with bootstrap tokens is that they get that big very quick. So if you get like 5 or 6 claims, which is nothing, you would cross that 64 KB boundary. And what that means is that if you have set up SharePoint 2010 with claims-based authentication, practically speaking, half of our users will not be able to log in because there are too many AD groups and their fed-auth cookie has gotten pretty big and SharePoint just cuts it off. That's not a problem with SharePoint 2013. Why? Because SharePoint 2013 never sends that fed-auth cookie out. Right? Segue number 2, if you're writing an iPhone app today, targeting Office 365, we have to do passive federation as of today. Now, down the road, they're going to solve this problem with the new Office 365 developer APIs that they will release down the road. They just declared about them at this SharePoint conference. And that will allow us to write native client APIs that use OAuth. And that's a much cleaner and better architecture, right? And they're going to work with Azure AD, and Azure AD supports OAuth too, right? But again, over there also, what you have to do is that you have to get the fed-auth token, and you have to save it, and you have to replay that fed-auth token over and over again. So you do passive federation in your code. Actually, that's the reason people are moving away from WS Federation, and people are going to OAuth, because in order to be able to do WS Federation, I would have to ask for your username password, and that would be a forms-based login written in HTML. So basically, I have to host the web access form inside of my native app. And we have, so how many of us here have like iPhones? Pretty common, right? And you've installed Skype on your iPhones, and you can sign in using a Microsoft account or Skype link. When you click on sign in using a Microsoft account, what does it do? It loads the browser. And then you provide your live ID, and then it takes you back. They're using WS Federation. Right? They're going to move to OAuth one day, and that's why the apps model and all that is superior. But anyway, it's a slight detour. CSOM supports both OAuth and REST API, and it's only going to get bigger from here. So you're going to see a lot of support for OAuth in the future. Now, let's come back here. Let's run to this line of code here. So this line of code over here, again, is doing something similar. It is going to load a bunch of lists, but it's running a link query to do that. So behind the scenes, it's going to work the same. Now let's look at being able to update the title of the site. Let me just see, every single request is re-authenticating because I turned distributed cache off. Let me just remove this. Now, the next is going to change the title of the site. So step 1, execute query. Step 2, web.title is equal to new title. Web.update. Okay, now I should have gone back to the server once already. Again, you see, re-authenticating over and over again. And this brings me to another point, which actually is the point that I started with originally and I got distracted. A lot of servers out there, the distributed cache is not set up properly in SharePoint 2013. And as a result, you are hitting the server with too many HTTP 401s. So what should have been just one request is 3 requests. And the H401s are actually very expensive because for the browser to say yes or no to a 401, it has to go talk to the domain controller also. Right? So, you should analyze your IIS logs and find out how many 401s you have. If you have more than 5% of your requests are 401, your servers are working way harder than they should. And I've done some performance, metrics on SharePoint environments of clients, and I tell you, I've seen as many as 60–70% of the requests were 401s. Just think about it. Just think of how hard the server is working over there. It's like one server, but you're using only 1/3 of it because 2/3 of it is being used for 401s. Just by turning distributed cache off. Anyway, let's come back here and try not to get distracted. The web.update execute query, and now it would have updated the title. As you see, process query is working. And come back here. And I'm going to come back to the site here, refresh, and I should see a new title appear. Bam. Cool? So this is CSOM. Now, we're supposed to get at 3:30, I have 25 minutes left. Let me change gears and start talking about REST API. REST API. Who likes REST? Everybody likes REST. Right? And I'm not talking about sleep REST, we like that. But I'm talking about representational state transfer because everybody supports it, right? Yahoo, Google, Azure, everybody has a REST API. So there's a reason people are going towards REST. It's simple, it's lightweight. Web API and MVC is all REST-based also. So REST is awesome. It is also technology agnostic. So all the existing investments you have on HTTP will work through your firewalls, right? REST is pretty cool. Now, when I go to www.google.com, for instance, I have Fiddler running over here. I'm going to go to www.google.com. Tell you what, let me clear Fiddler. I'm just going to go to google.com and see what's happening over here. Behind the scenes, it did a get/HTTP 1.1, and Google responded with a 302, which redirected me back to google.co.uk. And then I'm getting a 200, so I can enable HTTP encryption, but I'm not. So Google is nice, they use SSL for everything, that's awesome. Bing doesn't. But anyway, so if I go to bing.com, you'll see that's not SSL. Again, slight detour. Security is a very important, interesting topic too. I mean, you see I like to talk, but anyway. So if you go down here, you see basically what they're doing is that if I had enabled decryption, which I didn't, so let me look at the Bing request down here. And you see here that it's getting this JavaScript file here, But it's basically a GET request is what they're doing. See that? It's a GET request. Now, it's doing a GET request, and REST API works the same way. If I'm getting data, I do a GET request. But then they support a few other verbs: put, post, merge, patch, and delete. And there's another one called options. Now, all of these have different purposes, but the whole idea over here is that I'm accessing a very, very simple resource, and I can do get, or I can say post, and I can put some payload, and I'm able to both edit data and query for data using REST API. REST API is very, very powerful. Now you got two data formats that we can work with, Atom or JSON. Now the reason people created REST is because, with iPhones when they first came out, we had edge networks all over the place, and bandwidth was an issue. There was a very weak CPU and all of that. So people had a protocol back then called SOAP, and that was very big and heavy, and processing it was very difficult, and sending a lot of data, XML, blah, right? Now people said that this is really not a good serialization mechanism. We need something else. So then they came out with REST. And the thing with REST is I can say, if I want to get weather, I can say get server/weather, and it would give me the temperature as a number, 55, for instance, Fahrenheit, not Celsius, right? So that's cool, but what if I wanted weather forecast for 5 days? Now it had to give me a collection back. So how do we send a collection? Yeah, let's send XML. But then we're back to the original problem. So they first started with Atom. And the advantage of Atom is that it was strongly typed, right? But then the disadvantage was that you were back to the same problem in which you had the XML all over the place. And Atom is not the right format for the most commonly used client, which is JavaScript. JavaScript likes JSON. It stands for JavaScript Object Notation. And JavaScript is JSON is a serialization format that is perfect for JavaScript. It's been created for JavaScript. So what JSON allows me to do is that over here I can hit F12, and so this is Internet Explorer, okay? So I'm going to go to say console. Where is console? And I can say var person is equal to new object, and I can say person or first name is equal to Sahil. Person dot last name is equal to, go away, I'm a victim of software piracy, right? And I can say person, and that basically writes, that looks like JSON, right? I'm using IE10. Now, the same piece of code, so I can say JSON.stringify person, small s, and I can say alert on this, and that basically gives me the JSON representation of the object I created. Now what I'm going to do is that I'm going to paste this in Notepad, okay, and I'm going to take this, so basically I'm going to write some pseudo code based on that. So I can say var person is equal to, and I'm going to basically replace this with that, and come on, replace all, and I'm going to put quotes around it, and like that. Oh, come on. And I can say JSON.parse and paste in this object, and then I'm going to say alert person dot first name, and I'm going to basically take this code to a completely different machine in a completely different browser, go on a completely different site, and I'm going to basically open the developer toolbar. Where is that on here? Developer JavaScript console, and here in the console I'm going to basically write the same piece of code over here. And I screwed up. It's got no method called parse because it has to be with a lowercase p. And you see here that it's able to get the data. So this is the beauty of JSON. But see, JavaScript is a little weird, right? So for instance, let's come back here. In JavaScript, there are a lot of like weird hidden nuances. For instance, if I was to write code like this, okay, it's a little quiz. Var I is equal to 1, okay? And if I say if I equal to 1, then alert true. If I hit enter, will it alert or not?
Sure.
Okay, it does. Okay, cool. Now say var j is equal to 1, but this time I'm going to put quotes around 1. Okay, now I'm going to say if I equals j, alert true. What do you think will this do? It will. It does. But they're not equal. One is a string, another is number. Now if I say var k is equal to I plus j, what will this be?
Write it off.
2? 11. Now you see how bugs creep in JavaScript, right? So there's a site called yourlanguagesucks.com, and for that there's a page on that site called, for C#, which is about half a page long. Java is about 3/4 of a page long. JavaScript, the section is 7 pages long. The last time I checked, it's for a reason, right? JavaScript sucks, but we all deal with it because hey, it's the thing. It's the only thing that works everywhere. And as platforms, when we write code, it's going to run on all possible platforms. We have to support JavaScript. Anyway, JSON handles all this nicely. For instance, when we say var d is equal to new date, right? That's a date. But if I was to say JSON.stringify d, it gives me the right format for it. Did you see that? And now when this format goes over the wire, it understands time zones, for instance. I can convert this to a Swedish date format, which is YYYMMDD, right? It understands all of that. The Swedish date format is a royal pain. It really is.
Sorry?
Well, there is no parser built in for that in any language, right? That's the problem. But actually, mathematically, it makes the most sense because I can sort the easiest on it, right? But I can't tell you how many nights I've lost because of dates. And I'm talking computer dates, right? Anyway, let's come back to REST API. So, JSON is the right way to go, is my point, right? Because it really reduces the pain working with JavaScript. So, SharePoint 2010 had _vt_bin/listdata.svc. That still works, but they've replaced it with something called as _API, and I would strongly recommend that you start moving your code from listdata.svc to _API. Listdata.svc was basically created by the edu.net data access team, and they basically modeled it after what they did for databases. So they made some interesting choices over there, right? There are a lot of shortcomings in that API. _API is the SharePoint team's good attempt towards giving you good REST API for SharePoint. It actually works quite well. So, the SharePoint 2013 REST URL structure looks a little bit like this. Basically, you have a resource that you call _API, right? And then /, you can do indexers, you can do methods, and you can pass in parameters in there, and then you can have OData operations in the front. That's the general structure. Example, operations can be $select, $order by, right? And parameters can be, hey, I'm inserting this, or I want to apply this web template, so I can pass in the parameter web template ID, STS #0. STS #0 is what? Theme site, right? So, example, like this. What am I doing here? Get available web templates, and I'm passing in 2 parameters, right? So that's the structure of passing in parameters. So I'm accessing a resource, and I'm getting parameters. Next, you can also alias parameters. Sometimes what happens is that, I am accessing or trying to insert some data or something like that, And the parameter is just too long for me to type it in context over there. Like in this case, it's a JSON object. So rather than writing it in context, I could write @address and move the parameter outside of the main URL. Okay? Or I can also send parameters like a query string, like that. Now this is a little bit of a challenge because like, man, how do I remember all this? Right? So in beta 2, they had something called as $metadata that you could basically allow you to right-click add reference, write a link query and do a toString on the link query. It'll give you the string that you need to query. That was removed in RTM, but then it has been added again recently. But still, that's more of a hack. What they're doing for Office 365 going forward is that they have created a discovery API. So it's an API that lets you discover API. And that's the direction that they're leaning towards as of now. But in Office 365, $metadata tricks works also. You can use that. Then you have query operator support, right? So you can do $select, $expand. If it's a lookup sort of a column, I can get both the parent and the child using $expand. I can do paging, $top, $skip, $order by. So how hard would it be to write, simple paging on a data table using SharePoint REST API? Quite easy. Basically, I have $.ajax, and every time I hit next, I would just say $top is equal to, I just increment it. Right? It's pretty easy. Then I have some REST query operators supported. How many of us here are familiar with CAML, C-A-M-L? Right, SharePoint developers will know CAML. Now, you see over here that there are some things that are supported and there are some things that are not. And it's not very intuitive. It's like, why is it that starts with is supported but ends with is not supported? Right? You think, why didn't they support both? It sounds so intuitive. They should have supported both. Because CAML has only begins with. CAML doesn't have ends with. CAML has contains. So here you've got some string off. So basically when you execute a REST query, behind the scenes it turns it into a CAML query on the server. Now of course you do .items, that's not a CAML query. But if I do $select or if I put a operator, then I'm doing a CAML query. Now I have another talk which I'm not doing at this conference in which I show how to write good code for SharePoint. And basically simple examples that I show that the performance can change by thousands of times, right? Thousands, literally. Now, one takeaway from that talk that I'm not doing here is that you should always use CAML. Never do .items, right? And we don't have time to dive into why, but just take that as, just trust me on that. So when you do CAML, the same theory applies to CSOM, because through CSOM you can run CAML queries, and the same theory applies to REST API also. So don't do .items, do starts with, because it'll work a lot faster, if performance is important. Here's an example of running a simple REST call. _API/list, type is equal to get, and you pass in some headers, right? And then a success, error, and over here I'm basically going through the entire list and I'm filling out, whatever I queried over here. In my previous talk, my first talk this morning, I showed custom security trimming using search, and I called the REST API for search, and I used the code example almost exactly like this. There are some other examples here. How do I get the title of a list? How do I get a list of lists, particular list, and so on and so forth. So I have only 10 minutes left. Let me end with a quick example. Obviously there's a lot more over here, and for those that are attending my post-con workshop tomorrow, I'm going to go through REST API and CSOM in depth tomorrow in that. But for today, let me just quickly end with a simple example. So I'm going to go to SharePoint. Not this SharePoint, but not central admin, but the inside. I'm going to go ahead and add a little app. I'm going to say add an app. Let's close some windows here. Let's see this running. I'm going to go ahead and add an app, custom list, test, and inside of this app, I'm going to go ahead and add some data. Now, let's go ahead and add some data. 1, 2, 3, 4, 5, 6. Okay. Now, not bad for 12 gigs of RAM. Huh? It's running pretty fast. So, the challenge is that I want to be able to fetch these list items using REST API. How would I go about doing that? So, the first starter URL I'm going to hit is let's hope I can do this. HTTP SP_API. That's where we start. So let's go ahead and hit this URL. Haha, not found. _API/web. Alright, field format not supported because it is sending back JSON. But I'm going to pick the structure of that JSON from over here, Fiddler. So you come down here and you see here XML view. Actually, you know what? Let's do this. So we can read this easier. I'm going to go to Tools, Internet Options, Content, Settings, and I'm going to turn the feed reading view off. That way we'll see the XML here. And that requires restart of my browser. So I'm going to go ahead and try it again. Now we see the XML. Pretty cool. Alright, so it basically tells me that if I look through here, if I want to read the recycle bin, I would go to /recycle bin, for instance. Is there something called /list? Apparently there is. So I'm going to go to /web/lists. Okay? So if I go through here, this should give me, a list of all lists, and it sort of looks like that. So you see how I'm discovering the API as I go. So for instance, is there a list here called test? Yes, there is. It's called tests list. Okay? So let's go to /lists/tests list. Alright, not found. Obviously I messed up. So let's search for test list one more time. Test, I'll just search for test. Test list item, test. There's something called the get list by ID or something. Okay, /web list, maybe it's this GUID over here. I can obviously get that GUID in different ways also, but I think this will do for now. So let's select that, and now my URL looks like that. I think this should work, maybe. Let's try. No bad request. Okay, obviously I didn't pick the right demo for this. Let's see. I have the GUID. Well, this should have got, that's the ID, but where is the list items? Okay, let's read through this. Web list, GUID, web.
I think you missed the end parenthesis.
I'm missing an end parenthesis?
Yes.
Yes, you're right. Control C. Yeah, thanks. And over here, so this way, I can get a hold of one list, and then I can start looking at these properties over here, and somewhere here I should see fields, forms, and basically all the views, and somewhere here I should also see items. It's somewhere around here, right? Content types, event receivers. So basically this way, I can easily start, exploring the API and start discovering the API, right? So finding the REST API is actually very easy. So there used to be a product called as SPM SharePoint Manager.codeplex.com, which is a little exe you could download for free. Double click on it, and it basically shows you your entire SharePoint site, SharePoint farm as a tree view. The question is, can we use this mechanism to create something like that for just a site collection using REST API? Sure we can. They just say rel is equal to, that way you'll be able to basically create a simple tree view that lets you browse to the entire site. And that is SharePoint Manager for Office 365 that is available on the App Store right now. Cool? So, There's obviously a lot more content. It's always good to have more content than time. But with that, this is my last session of this conference. So I hope you enjoyed it. Hopefully you got something useful out of it. And I have a post-con tomorrow, so hopefully I'll see some of you over there as well. And with that, I'd like to thank you very much and I'd like to take any questions you have at this time. Thanks.